In this lecture, we will go through a practical introduction to Kubernetes. Let's get started. Let's recap what we learned in the previous section about Docker and containers. An image is the template that you can use to create a container. A container is a running instance of an image. Its process is isolated from all other processes on the host machine, and it has its own file system which is cloned from an image. Docker is a container runtime platform that enables you to build container images, share them on a registry, and create running containers based on the container images. Containers share the operating system kernel on the host. Therefore, there is no guest operating system overhead, but also there is less isolation between containers. Containers are lightweight compared to virtual machines. Therefore, a host can run tens of containers compared to a few virtual machines. Enter Kubernetes. The name Kubernetes originates from Greek, meaning helmsman or pilot. Kubernetes is usually abbreviated as K8s. K8s as an abbreviation results from counting the 8 letters between the K and the S. Kubernetes helps you manage your containerized workloads. We will see what that means in a moment, but let's first start with an example application. Let's assume you have a 3-tier application composed of a web app front end, a controller middle tier, and a back-end tier. Each tier is containerized in its own container image. To improve the scalability of your application and to better utilize infrastructure, you will want to have multiple running containers from each tier. The need arises for a system that supports the following features. Scale up or scale down your application according to incoming traffic, preferably scaling the number of running containers in each tier independently from each other tier. Load balance requests to each tier among its containers. Keep an eye on the health of containers. If a container crashes, start a new one. Roll out new versions of containers with minimal downtime. Roll back containers to a previous version. Make sure your application is highly available through horizontal scaling by running multiple containers on multiple infrastructure nodes. Kubernetes provides all the above features to you and then some. Let's explore some of the constructs of Kubernetes. Let's start with the Kubernetes pod. A Kubernetes pod is the smallest deployable unit of computing that you can create and manage in Kubernetes. A pod encapsulates one or more containers with shared storage and network resources and a specification for how to run containers. Most of the time, you will have one container per pod. However, there are use cases where it makes sense for a pod to run multiple containers. For example, you might have a container that acts as a web server for files in a shared volume and a separate sidecar container that updates those files from a remote source. Moving on to the Kubernetes node. A Kubernetes setup contains one or more nodes and is called a cluster. A node may be a virtual or a physical machine depending on the cluster. A node will have a container runtime such as Docker to run your containers. Kubernetes runs your workloads by placing containers into pods to run on nodes. Typically, you have several nodes in a cluster. However, in a learning or resource-limited environment, such as Docker Desktop, you might have only one node. There are two types of node. Worker node. This node hosts the pods that are the components of the application workload. Control plane. This node manages the worker nodes and the pods in the cluster. Here is a simplified overview of what the Kubernetes cluster does when you instruct it to run a pod. You issue a command to deploy a pod, say one pod of the Hello World container. The command can be issued using Kubernetes kubectl command line tool. The kubectl tool invokes the API server on the control plane node, telling it to please run one node with these given specs, one container of the Hello World container image. The API server on the control plane communicates with the worker node via its kubelet, asking it to launch the said pod. The kubelet, which is an agent that runs on each worker node, creates the pod on that node with the given specs. Going back to our 3-tier application, assume you want Kubernetes to deploy 7 pods of the web app, 4 pods of the controller, and 3 pods of the backend. The control plane node's API server will communicate with each worker node via its kubelet to create the pods. It will make sure you always have the specified number of pods from each tier, and it will distribute them across multiple nodes to ensure fault tolerance and high availability. Moving on to the Kubernetes ReplicaSet. A replica set is the Kubernetes resource that you can use to ensure you have a set number of pods running at any given time. For example, you can have 3 replica sets to ensure you always have 7 pods of the web app, 4 pods of the controller, and 3 pods of the backend. If a pod would crash, the respective replica set will replace it with a new pod. Furthermore, you can scale out or scale in a replica set as needed. Say you have a higher load expected during a sale event. You can scale out the web app replica set to 15 pods during the event. Then, after the sale event is over, you can scale it back in to 7 pods. Moving on to the Kubernetes deployment. A deployment is a Kubernetes resource that owns a replica set and provides more features on top of it. An important feature of the deployment is the deployment strategy, where you can declare what happens when you deploy a new version of your application. Let's say you currently have version 1 deployed and you would like to deploy version 2 gradually, meaning upgrading one pod at a time from version 1 to version 2 to avoid service downtime. A deployment with its deployment strategy set to rolling update can do just that. Like the replica set, you can also scale out or scale in a deployment to change the number of pods in it. Furthermore, a deployment provides you with more features. You can monitor the status of a deployment while the updates take place, from version 1 to version 2 for instance. You can pause or resume an ongoing deployment, see a history of revisions of a deployment, or roll back a deployment to a previous revision. Given that a deployment owns a replica set and adds more features, it is recommended to use a deployment instead of a replica set. Moving on to the Kubernetes Service. A Kubernetes service exposes a set of pods as a single endpoint. While Kubernetes gives each pod its own IP address, a service provides a single DNS name for all the pods behind it. A client invokes the service, and the service forwards the requests to several pods and load balances the requests among the pods. Going back to our 3-tier application, Each tier's set of pods can be exposed using a service. Let's recap what we learned in this lecture about Kubernetes. We started with a recap of containers and Docker, went through Kubernetes concepts, and explored several of Kubernetes constructs, namely pod, node, ReplicaSet, deployment, and service. Do not worry if this feels like too much info at once. This is just an overview, and we will tackle each item separately in its own lab. Remember, we are building a microservices application in this course. In each of the coming labs, you will build a part of this application. That's it for this lecture. Head over to the next lab where you will create a REST API server in a Kubernetes pod.